I mentioned that there are different methods in the theoretical section. I talked about regularization, decreasing complexity. Sometimes decreasing complexity is not an option when you have complex data. But I also talked about the dropout layers for mitigating overfitting. So dropout, as I mentioned before, is when you have a layer, a hidden layer in your neural network, and you basically randomly select a portion of neurons to be ignored in that model fitting pass, in that weight update pass, in that specific epoch. So in each epoch, you randomly pick a certain number of neurons. Usually you set a proportion between 20% to 50% of the neurons in that layer to be ignored. So the model is still complex, but it's more skeptical about the data. So we can do that kind of implementation in TensorFlow with a very simple function. Let's first implement a neural network that is relatively complex. We have 4 total layers. The first 3 layers have 32 neurons, and all of them, except the output, are nonlinear. So let's see how many parameters we have here. Let's take a look at the result. Let's see. We have a little bit more than 2,000 trainable parameters, like 2,000 weights and biases. And if we want to take this model here and include the dropout technique that I was talking about, you're going to see that it's very simple. It's very simple. You take that same model, and after each layer, so you see this is the layer we added before. After each layer, you add the function called layers dropout. So there's a dropout function pre-implemented in TensorFlow, so you don't have to manually disable neurons, which would be a pain. You add a layer on top of that previous layer to tell TensorFlow that you want to ignore a portion, you want to drop out a portion of the neurons. And the rate here we are setting is 40%. That is a tweakable parameter depending on the problem, on the data you're dealing with. You may have to change that proportion to see which one is the best for your data. But let's stick with an example here with 40%. And let's do that for all the layers except for the output, of course. We cannot ignore the output. So that's usually how we implement. Take all the input and hidden layers. And after each one of the layers, after we implement each one of the layers, we also implement a dropout function like this. It's just a TF-char as layers dropout. And we set a proportion. So that gives us pretty much the same architecture, but between layers here, you see after each layer, now we have the dropout that we didn't have before. So this, you can check if your model was implemented correctly. And then you can basically try to fit that model. I'm going to show here, for example, the same thing as we did before, creating a synthetic data set. We're going to split the data into train and validation portions. We're going to fix a test size of 40. Also, we don't need to set a proportion of test size. We can set the actual absolute number of observations that we want in the test size. So here I'm setting 40. I'm going to do the same thing as before. Same process, same standard process. We're going to split things into batches. We're going to build our model, and we're going to try to fit our data. So first we are fitting a model without the dropout. Let's see how the results looks like. Taking a little bit longer, set a little bit larger number of epochs again, because the complexity is higher. So it may take a little bit longer to fit all the model parameters. So let's have our baseline for comparison here without a dropout first. You can see I'm not including any dropout. So in blue, we have our original data points for the training data. In orange, we have our validation data points. And then in green, we have our fit data points. So without the dropout, looks like that rather than we having a straight line that is fitting to the data, we are actually fitting each one of the data points with the predictions with our model without dropout. So we are basically fitting to the noise. So we should not fit so perfectly like this to the training data points, and we are far away from the validation data points. So that's a sign of overfitting. So now we have a session in the assignment that asks you to do the same implementation again, but adding the dropout layers as is demonstrated before here. So take this model and put it here and do the same training again, but then tell me in the quiz questions, it's gonna ask you to tell me what exactly do you see? Do you see some improvement or not? So that's gonna be basically your assignment for module number 4. So you're gonna answer that in the quiz. So hopefully when you add the dropout, you're gonna see that the green, the predicted values, they will not fit so perfectly to the training data, and they will fit a little bit better to the validation data here. So you're gonna see a loss that is not so different between the training and the validation data.